We have done Laplace transform, and now is the turn of inverse Laplace transform. We say Laplace of 1 is 1 over s. So Laplace inverse of 1 over s is 1. This works exactly the same as any other inverse function in mathematics works. So if Laplace of cos of 3t is s over s square minus 9, then Laplace inverse of s over s square minus 9 is cos 3t. So it's as simple as that. Now, let's see on the table again. Now we are going to use this part of the table where we have listed inverse Laplace transforms. They are almost exactly the same as the Laplace transform. Laplace of 1 is 1 over s. Laplace inverse of 1 over s is 1. Laplace of t power n is n factorial over Sn plus 1. Note the difference between this n plus 1 and this is n, 1 less, and this is n, 1 less. So let's say if this is 4, s power 4, this will be 3 factorial and this will be 3. So if we take inverse of 1 over Sn, then this will be 1 over n minus 1 factorial, t power n minus 1. So just this one goes down here, this one goes down here, and the rest is just simple uh, shift. Laplace of e power at is 1 over s minus a. So Laplace inverse of s minus a is e power at. Very simple, straightforward. Sine of kt, we have a k. This k is constant, so this k shall go down here. So this becomes Laplace inverse of 1 over s square plus k square, 1 over k sine of kt. Same as the others, but this one cos, there is an s here. S is not a constant. It's part of the formula which does not change, s and s square. So here we don't have 1 over s because s is not constant. It's not going outside Laplace inverse. It stays inside, and uh, because k is the only constant in the formula. Right. So let's say we are doing Laplace inverse of 1 over s square plus 4. The first thing we need to figure out is plus. So we see the sign plus here. So which one is the one which is applicable? We have a plus with s square and plus. So s square and plus, it comes in sine formula. In cosine formula also we see s square and plus, but cosine formula has an s at the top. We don't have an s at the top here. It means it is sine formula. So if it is sine formula, we need to know what is k. Here we have a 4, which can be written as 2 square. So it means k is 2. And so if k is 2, then our answer is 1 over 2 sine of 2t, 1 over k sine of kt. Right. Note one thing, very important. We will use it later. I did mention it before that Laplace of a function of t is written as function of s, as we can see here on this side of the table. Laplace inverse applies on function of s and gives function of t in answer. Okay, so this difference is very important to note. When we take Laplace, we apply it on a function of t, and answer is function of s. K is not the variable. K is a constant which we put and becomes a number. So function is only t here and s here. For inverse, we start with function of s on the left side and we get a function of t on the right side. Again, k and a and n, these are numbers. They will become numbers just like we see here. So we start with a function of s and we get a function of t. This k we put as 2, so that doesn't make function. Right. How about this one? 1 over s power 4. Now we are going to do this formula. Laplace inverse of 1 over Sn, 1 over n minus 1 factorial, t power n minus 1. So we have to do one less. 4, our n is 4, so 4 minus 1, t power 4 minus 1, 1 over 3 factorial, 1 over 3 factorial, t power 3, 4 minus 1. And 3 factorial is 6, so that's the answer. Let's just check whether our answer is correct or not, just in case. So, what was the formula for Laplace of t power n? It was n factorial over Sn plus 1. Okay. So, if I take Laplace of this function, I must get 1 over S4. Let's see. So, I take Laplace of 1 over 6 t cube. Okay. 1 over 6 t cube, this function here. 1 over 6 is a constant. It goes outside. And we take Laplace of t cube. This formula tells me 3 factorial over s power 3 plus 1. 3 factorial is 6. S power 3 plus 1 is 4. 6 and 6 cancel. 1 over s power 4. Exactly the same. It means our answer for Laplace inverse is correct. All right. So let's proceed further. How about Laplace inverse of s plus 1 cube over s power 4? Inverse is a linear operator, just like Laplace. If there are two functions with the addition or subtraction, we can split Laplace, make separate Laplace for S and separate for G. Same is the case with inverse. If there are two functions inside the bracket and there's a Laplace inverse outside, we can take a separate Laplace for inverse for F and a separate inverse for G. But the problem with this question is a cube outside. Laplace inverse cannot go inside the cube. We have to expand the cube first, then we can take the inverse inside, maybe. But there may be one more step actually. So let's expand the cube. So s plus 1 cube using this formula, a plus b cube, a cube plus 3a square b plus 3ab square plus b cube. Put the values of a and b, s and 1. We get this thing. So that is our s plus 1 cube. Now still it is not in the shape of f plus minus g, two separate terms. We want it to look like this way, f plus minus g, and not a single fraction. So what we are going to do is we are going to use a plus b over c, which is a over c plus b over c. We can split the numerator. Okay, so s cube over s4, 3s square over s4, 3s over s4, and 1 over s4. We can simplify the terms, cancellations, and we get this 1 over s, 1 over 3 over s square, 3 over s cube, and 1 over s4. Now Laplace inverse can go inside and it will apply on all four terms one by one. Yeah, one thing to remember though. C over A plus B is not equal to C over A plus A over C over B. We cannot split denominator. Please don't split the denominator. Right. So Laplace inverse of 1 over S, which is 1. 3 over s squared, 3 goes out, 1 over s squared with n equals 2 becomes 1 over 1 factorial. Okay, we are again using the same formula which we just used in the previous example. 1 over Sn equals 1 over n minus 1 factorial t power n minus 1. We have to subtract 1 from n on the right side. So if n is 2, so it becomes 1 factorial, 1 power. If n is 3, it becomes 2 factorial, 2 power. If n is 4, it becomes 3 factorial, 3 power. And then we can write one last step to simplify the factorials. And that's our Laplace inverse. Right, let's try one more example. Laplace inverse of 10s over s square plus 16. Question is, can I write Laplace inverse of 10 over s square plus 16? So I separate it here and s over s square plus 16. What do you say? Pause the video, think about it. What is your vote? Let's continue. So if your vote is yes, Well, of course, you can see the crosses on the screen. I hope you got it already. As I said, these notes were transcribed in a previous attempt to record videos, and because of some audio problem, I'm recording them again. Right, so 2 multiply 5 over 7 cannot be equal to 2 over 7 multiply 5 over 7, clearly. So you cannot split them like that. So we do is we send 10 out because it is constant. 10 goes out. We get s over s square plus 16. This is our cosine formula straight away because there's a plus here and s square here, s at the top, all the symbols of cosine formula. S at the top, s square plus, so that is cosine formula. S at the top, s square, but with a minus, that's hyperbolic. But we have a plus, so it's cosine formula. But we need is k. To write the answer, we need k. So 16, we write it 4 square, it means k is 4. So 10 cosine 4t is our answer. Right, so let's do some more problems of inverse Laplace transform. This is question number 9 in our exercise. Question number 9, exercise 4.2. Laplace inverse of 1 over 4s minus 1. Okay, for this one, I would like you to vote. Okay, choose which one is the answer. Just make a guess. Okay, first option is 1 by 4 e power t. Second option is e power 4t. Let me write for your quick hint the formula for inverse in this situation, which we can use. So Laplace inverse of 1 over s minus a, this one is a, equals e power at. Now this 4s can be a bit of problem, or is it a problem? Okay, raise your hands and vote for 1 or 2. Okay, votes for 1. How many votes do we have for 1? Votes for 2. Okay, so we got the votes in. And the correct answer is no, not 1, not 2 either. Right. So those who have voted for 1, they are not correct, and those who have voted for 2 also not correct. Okay, that was the good news part. Let's see why. Let me move this thing over here. So let us move it over here. Right. So what is Laplace of this thing? What if I take Laplace of 1 over 4t? What do I get? Okay, so I get 1 over 4 because it's a constant and it stays outside. Then 1 over s minus a, where a is 1 in this case, which if I would like to, I can write as 1 over 4s minus 4. 4 will multiply both s and 1 because it's outside. But that is not what we are looking for. 4s minus 1 is what we are looking for. So this one is wrong. Why the second one is wrong? Let's see. So if we take Laplace of e power 4t, then it is 1 over s minus a, which is 4 this time. Still, it's not the answer we are looking for. So what is the answer then? For this one, we are going to take common. 4s minus 1 equals 4 times s minus 1 by 4. Why do we write 1 by 4? Well, let's see. Let's say if you have 3x minus 9 and you take 3 common. How does that work? So we divide by 3 and we divide by 3 and we get 3 times x minus 3. Is that right? So from here, when you take 3 common, 3 is gone out, we get x here and minus 3 because we divide 3 inside on both terms. Similarly, for 4s minus 1, when we take 4 common, we divide this by 4, we divide this by 4, and we get s minus 1 by 4. All right, now let's go back to our question. Our question was Laplace inverse of 1 over 4s minus 1. So this becomes 1 over 4 common s minus 1 by 4, right? Now this 4 is a multiplied 4 and it can go outside of the inverse. We can write 1 by 4 Laplace inverse of 1 over s minus 1 by 4. Our formula, let's look at the formula again if we have written it recently. Laplace inverse of 1 over s minus a. Now you see, nothing is multiplied with s here. That's why we don't want this 4 here. We have to take it out. But we cannot take this 4 out without taking common. So we had to take a common. Right. So 1 over s minus a, okay, e power at. This a will go in the power of e. All right. So now we have exactly the situation which is given in the formula. Laplace of 1 over s minus a equals e power at. Our a is 1 by 4 now. So this becomes 1 by 4, which is outside here, over here, that's still there. And e power 1 by 4t. That is our answer. So Laplace inverse of 1 over 4s minus 1 is 1 by 4 e power 1 by 4 t. Okay. Let's solve another kind of similar problem. Question number 13. Laplace inverse of 4s over 4s square plus 1. The closest match in the formulas, let me move this one a little bit here so that we can make up some space. Yeah, that's better. Right. So the closest match with this formula, it is s at the top and a s square plus 1 here in the denominator. Let's go to our formula sheet and you can open your formula sheet in front of you and have a look. All right. Uh, s over s square plus. This one seems to be the closest match because this does not have an s at the top, the sign one, no s at the top. This one has an s at the top but minus in the denominator. So this one is the closest match. It means it can be cosine kt. But then again, let me write the formula here. S over s square plus k square equals cos of kt. As we can see, and as we did see in the previous formula, we do not want anything here. No constants multiplied with a square, but we do have a constant multiplied with a square. It is 4. And we also have a constant multiplied with s up here. Both the constants has to go out. All right, pause the video, give it a try. Okay, so now you have tried it. Let's see how it works. Well, the top constant, this 4 can easily go out. There is no problem there because it's only linearly multiplied. So this goes out and we get 4s square plus 1. To take this denominator 4 out, we have to use the same algebra step. We have to take common from here s square plus 1 by 4, it is exactly the same as we did in the previous example. So we have uh, 4s square plus 1. We write 4 common, 4s square over 4 plus 1 over 4, and that gives s square plus 1 by 4. Let me change the marker. This is no need to be. I use this darker pen on the when I'm presenting in class. So right now I don't need it. Right. So now we have a situation exactly like this formula here. S, no number here, so we don't have any number here. We need to take this S out first. Okay, so let's take this S out first. This one, 4 over 4 Laplace inverse of, because now this 4 is multiplied with a bracket, so it can go out. S square plus 1 by 4. Now we have the situation as in the formula. No number here, no number here, no number here, no number here. Now we can use the formula. But before we use the formula, we need to figure out what is k over here. So k square equals 1 by 4. K square equals 1 by 4. If k square is 1 by 4, then k should be 1 by 2. It means our answer is cos 1 by 2t. Okay, so that's our final answer. 4 and 4, they cancel out on the outside. This 4 and this 4, they cancel out and they give 1. Right, let's do one last problem. In this one is Laplace inverse of 1 minus 3s over s plus 4. S square plus 4. Okay. Right. So pause the video again and have a quick look at the problem. How would you do it? There is no formula which can directly solve the question in one step. None of the formulas have a situation like 1 minus 3s or anything like this at the top. The the formulas we have, they have either a constant at the top, you see, either a constant at the top, 1, or s only, not s plus 1 or s minus 1 or situation like that. So how would we do this then? Let's see. So first of all, we will use the same reasoning we have already used. A over c plus d, b over c plus d. And once again, I would like to remind you that do not split the denominator. So this becomes Laplace inverse 1 over s square plus 4 minus 3s over s square plus 4. Now we can split the Laplace inverse over two functions. 1 over s square plus 4 minus Laplace inverse of 3s over s square plus 4. Now the difference between the two is this one has a 1 at the top and this one has an s at the top. So that differentiates between the two. This one will become sine 1 by 2 sine 2t, and this one 3 is going to come out. 3 is going to come out here, and then cos 3 cos 2t. In case of cos, we do not divide by k, so that's why no divided by 2 in case of cos. Okay, please keep your formula sheet in front. Laplace inverse of 1 over s square plus k square, 1 over k sine of kt. So k is the square root of this term. Okay, so we have 4, so k is 2. And for cosine formula, it is s over s square plus k square, and it is simply cos kt, no 1 over k outside. Okay, so this only 3 is outside, but not 1 over 2.